In this video, we want to evaluate the integral given here using two methods, U-substitution and using partial fractions. This is just to show you that there's more than one way to work a problem. If you're taking a final exam especially, and you could have integration of different types of problems, and some can only be done by one method. Others will have options. It will be up to you to decide which method to use unless the instructions tell you to work in a certain way. So this one we're going to do it first by substitution. It should be clear that the integrand 2x over x plus 1 squared can be broken down or decomposed by partial fractions. So here we'll go ahead and I'm going to let u equal to x plus 1. And if you've done enough problems using this u substitution, you know that there's more options here. Sometimes you can let u be a different quantity and it still might work out. In this case, I'll go this route. Say du then, derivative of the right side is 1. So that'll be dx. So that would tell me that du and dx are interchangeable. Remember, the objective here with the u substitution is to convert this integrand into an expression involving u instead of x. So this should equal to then dx and du are the same thing. So I can replace the du with the dx by du. And the denominator x plus 1 can be replaced by u, so this will be u squared. And we still have an x in the numerator, but from this expression here, this equation u equal to x plus 1, we can solve for x, and that would be taking the 1 over. We could say that x is equal to u minus 1. So replace the x here. This will be 2, and then the x can be replaced by u minus 1. So then this can be broken down, or equal to. So here we'll go ahead and multiply by 2 and then divide by u squared. So this will be 2u, but let's go ahead and do this, and then this over u squared. So this will reduce down to u to the first here. Let's take it to the numerator. So this will be u to the negative 1. Then minus 2. We got a u squared down here. Let's take it up to the numerator, make that a u to the negative 2. And then this is just like using the basic power rule here for integration. We add 1 to this one here, but remember this is 1 over u, so the integral of that would be, look at this, it's 1 over u, the integral of that would be ln of absolute u, minus, and then the next one there, we can add the negative 1, or add 1 I should say. So add 1 to the negative 2, that gives me a negative 1. We divide the coefficient by that, that's going to be plus 2 here. And then plus a constant. So now all we have to do is go back to the original variable. Doing a u substitution, or a trig substitution in some cases, always want to go back to the original variable. So this will be 2 ln absolute u, and u is x plus 1. Then we have plus 2. That's u to the negative 1. But again, u is equal to x plus 1. And you have your constant of integration. So you can write this 2x plus 1 to the negative 1. You can write that as 2 over x plus 1 if you want. Same thing. But that's your solution using the u substitution. So that's the value of this integral here. If we're going to use partial fractions, set it up this way. 2x over x plus 1 at x plus 1 squared. And this is a case where you have linear factors that are repeated. So the method here is to say, okay, this can be broken down as some constant over x plus 1 plus another constant b over x plus 1 to the second. Now if that were an exponent of 3, then I would go again and say plus c over x plus 1 to the third. But in this case, that's all we need. And then we just find the value of a and b, and then apply the integration technique here. So what we'll do here is multiply both sides by x plus 1 to the second. So multiplying the left side by x plus 1 to the second would just give me a 2x. Multiplying the first expression on the right side by x plus 1 squared cancels one of the x plus 1s and it'll leave me with a x plus 1. Then multiplying the second term, b over x plus 1 squared, by x plus 1 squared, the x plus 1 cancels and I just get a b. Now, you have several options here to find the value of a and b. I could set this up as a linear expression over here. Set it up this way. Okay, got ax. Multiply through by a. And then a times 1 is a. So over here I get a plus b. And just treat this as your constant. And over here we have a first degree expression, polynomial on the left side. The same thing on the right side. So the corresponding coefficient should equal. So coefficient of x to the first here on the left side is 2. On the right side it's a. So that tells me that a has to be 2. And a plus b is the constant on the right side. Has to equal to the constant on the left side. Well, there's no constant there, so that's 0. So we have a little system here to solve. We already know a, so plug in a over here for equal to 2. So this is 2. So b should equal to negative 2. So now, on the right side, I know I can expand this using partial fraction decomposition. So instead of 2x over x plus 1 squared, this can become this right here. With the value of a being 2, the value of b being negative 2. So this would be 2 over x plus 1 plus b is negative 2 over x plus 1 squared. And now we just integrate each expression. 2 over x plus 1 should be clear that the integral of that is 2 times the natural log of x plus 1. I could use a U-substitution here and say u equal to x plus 1, but all we'd come up with is 1 over u times the 2 du integral, and that using the formula that the integral of 1 over u du is absolute natural log of absolute u. So I actually need absolute values here. If this were an x squared, then I wouldn't need the absolute values, but that couldn't be that wouldn't be negative. Now for this one the same way, minus 2 over x plus 1 squared. U could be x plus 1, but again you should be able to see that if I let u equal to x plus 1, then dx and du would be the same. And this would just be a u, so it would be the same thing as integrating u to the negative 2. So if I add 1 to that. That'll give me negative 1 divided by negative 1. So the minus 2 becomes a plus 2. And this becomes a u to negative 1. But here it's x plus 1. So this will be x plus 1. To the negative 1. Plus the constant. So the answer again is 2 times the natural log of absolute x plus 1 plus 2. And you can write this as 2 over x plus 1 instead of 2x plus 1 to the negative 1 plus a constant. And that's the same answer that we got using the regular U-substitution. So again, this is just to show you that there's more than one approach. Sometimes you pick one that takes a little bit longer than the other. So always take the one that's easier and takes less time. Thanks for watching. We'll see you next time.